Good morning, dear students. Today we will discuss in this lecture what is remote sensing, its history, and remote sensing process. I am Kuldeep B. Patel, Assistant Professor in Department of Civil Engineering, Government Engineering College, Bhuj. So let's first of all understand what is remote. Remote means far away, and sensing means believing or observing or acquiring some information. So in general, if we combine these two words, remote sensing, it means acquiring information of things from a distance with sensor without touching the things. Okay, so remote sensing means in that we are acquiring the information. We have satellites, and in that satellites we have some sensor. That sensor are gathering or collecting some information from the object which are on the earth surface, but without touching, without coming in physical contact with it. Sensors are like simple cameras, okay, except that they not only use visible light but also other bands of electromagnetic spectrum such as infrared, microwaves and ultraviolet regions also. So the definition, if we want to say technically, the art, science and technology of obtaining reliable information about physical object and the environment through the process of recording, measuring and interpreting imaginary and digital representative of energy pattern derived from non-contact sensor system. According to India's National Remote Sensing Agency, they have defined remote sensing is the technique of acquiring information about objects on the earth's surface without physically coming into contact with them. Okay, so this is the general meaning of remote sensing. Now, if we want to say what are the example of remote sensing, so first example we can say our eyesight. Our eyesight is a form of remote sensing. When the eye sees an object, the electromagnetic radiation, reflected light, which is reflected light from the surface of the object is registered, and the radiation contains information about the surface, and we see color and form. A scanner in a satellite is also record the electromagnetic radiation. Cameras on satellites and aeroplane take images of large area on the earth's surface, allowing us to see much more than we can see when standing on the ground. So these are the various example of remote sensing. Even our sonograph, X-ray is also example of remote sensing, because here we are acquiring the information without coming in physical contact with it. Okay, so we have discussed up till now what is remote sensing, its definition as well as example of remote sensing. Now we will see some of the history of the remote sensing, how it evolves. So aerial photography is the original form of remote sensing which we can see in a visible spectrum, which is started in 1909. Color infrared photography began in 1931, then was widely used in the agriculture and forestry. Development of radar, which is in 1930 to 1940. Non-visible spectrum, which is infrared and radar, were used as a tool in remote sensing. After the first man-made satellite Sputnik 1 was launched on 4th October 1957 by Soviet Union, remote sensing moved to the outer space, ignited the space race within the Cold War. The United States Explorer 6 transmitted the first space photograph of the Earth in August 1959. Hyperspectral remote sensing emerged 1980 widely used in the mineral, oil, etc. exploration. Since then, a large number and advanced types of remote sensing system have been developed. Okay, so I have given in a very brief history of the remote sensing. Now we'll move further about remote sensing process. Okay, so you can see this is the general diagram. We'll explain in detail also that we have this solar energy which has some source of illumination, and that energy comes in the atmosphere through the earth surface and interact with the atmosphere, and finally with the earth surface. That radiation interact with the atmosphere as well as with the earth surface, and that earth surface absorbs some of the energy, and some of the energy is reflected back from these trees, grass, okay, buildings, and that are collected to satellites. In satellite there are some sensors are there, they are collecting that, and that data are transmitted to the transmission station, and where some analysis and interpretation process is generally happening. Okay, so to understand this, first of all we have to understand that to happen this particular process we require some source of energy. Suppose right now I am sitting in front of you, and camera is focusing on me, and means the camera sensing me. And what is the source of energy? You can see here two spotlights are there, bulbs are there. So bulb has some energy and camera is sensing me. So source of energy is here bulb. But suppose there is no light here, only camera is focusing me, is sensing me, but there is no light. So you can't see me. So same way here, for remote sensing process, some source of energy is required. So you can see there are 7 steps are there for remote sensing process, and they are dictated here as A, B, C, D, E, F, G. So first process, that is energy source, as I told you, that is A. So here what will happen, the first requirement for the remote sensing is to have an energy source which illuminate or provide electromagnetic energy to the target of instrument. Second one is radiation atmosphere, that is B. So as I told you, sun has some energy, and from that energy, that is radiation, is traveling to the earth surface. So as the energy travels from its source to the target, it will come in contact with or interact with the atmosphere, that is B, and it passes through, and this interaction may take place a second as the energy travels from the target to the center. So that is second one is radiation and atmosphere, second step. Then third step, that is C, interaction with the target. So once the energy makes its way to the target through the atmosphere, it interacts with the target depending upon the properties of both the target and radiation. So first one is energy source. From that, radiation is coming interaction with the atmosphere, and then it comes in interaction with the target. Then fourth process is recording of the energy by the sensor, that is D. So after the energy has been scattered by emitted from the target, we required a sensor that is remote, not in contact with the target, to collect and record the electromagnetic radiation. So whatever energy is absorbed by, some of the energy absorbed by the target, that target means building, roads, trees, and some of the energy then reflected back and collected by the sensor, which is fitted in the satellite. Then fifth process is transmission, reception and processing, that is E. You can see in the figure. I will show you this one. Okay. So the energy required by the sensor, means this one, has to be transmitted often in electronic form to receive and processing section where the data are processed into an image, that is hard copy and digital. So here it will be processed. Then sixth process, interpretation and analysis. The processed image is interpreted in two types, visually and digitally, to extract information about the target which was illuminated. So you can see this is your sixth process of remote sensing. And after the seventh one is, that is G. The final element of remote sensing process is achieved when we apply the information. Okay, we have been able to extract from the imaginary about the target in order to better understand and reveal some new information. Okay, so we can, using this remote sensing application, for example, if you want to know about the agriculture, if you want to use remote sensing in agriculture, so you can know the crop condition, which type of crop you want to take. You can also know the crop yield with the help of remote sensing. If you take example of remote sensing in geology, so you can know what are the various types of rocks are there, what are the various rock structures are there. Okay, so there are various applications of remote sensing. Okay, so these are the 7 steps of remote sensing process. Now I will show you one video. By seeing this video you can easily understand the phenomena behind this.